first class of the course, the near-infrared reflectance spectrometer for art examination. So this is basically a spectrometer with an INGA-AS detector. So we go from 930 nanometer until 1670 nanometer. For this first class, we are going to examine this parchment. It has some colors, blue, the red, and the ink. When we use the reflectance spectrometers, they work well with some pigments. With others, we don't get any specific signal. There are some pigments where these tools can work pretty well, so they have very characteristic features. So the advantage of this kind of equipment is very important in this case, because we can get the signal, we can get the information in a few seconds doing the examination without any sampling. So whenever it works, the system is pretty fine. Okay, so we start the acquisition. So here on my back we have the software. First of all, we have to calibrate the system, so we use a spectral on as a white reference. We tune on the lamp and we do the acquisition. Okay, this is the background acquisition. We go here now in percentage to do an actual reflectance measurement. Okay, and you see we have a flat line. So the flat line means that this is the calibration is fine. So we can proceed to measure the colors in this parchment over here. So we start with the blue. It's the one that we actually want to look at. We measure also the parchment, because the parchment will be the background of our measurement when we do reflectance spectroscopy. Okay, 6, 5, so we are making a little bit of average. Okay, so we acquire this spectrum from the parchment, and now we go into the blue. Okay, 3, 2, 1, average, and there it is. At this point, we can load the spectra into Spectrograph. That is the software that I use for comparing Raman spectra, FTIR, reflectance spectroscopy spectra. So we load the spectrum from the parchment. So there it is. Now we load also the spectrum of the blue color that we saw on the parchment. Okay, so we have a parchment, the black one, and the blue spectrum is the actual blue color. What are the main features of this blue spectrum? Over here in this area we see that the spectrum goes down, so there is some absorbance, but these absorbance basically overlap that of the parchment itself, which as we know in the reflectance spectroscopy will contribute to the final spectrum of the pigment on top of some support. So what we see here that is interesting is this absorbance band over here that is very clear in this area. So actually at 1500. Among all the blue pigments that this could be, you will look for the pigment that has this absorbance band. So you need a database of this spectra. So on our website chsopensource.org and the pigments checker page, you can find the spectra acquired with this equipment from the pigment checker. And the blue that has the best overlapping, the spectrum of azurite. There it is. So you see this absorption under 1500 is a feature of azurite. So using this simple technique we can check immediately, very easy, very portable, if this one is azurite. Thank you.